In this video, we will complete practice exam 2 in differential and integral calculus. And we will start from question 6. The curve of the function f, where f of x equals 2x power 3 plus 3x squared minus 12x plus 5, has inflection point at x equals. Now, to find the inflection point, we must find the second derivative. So, to get the second derivative, first we will make the first derivative. So, f dash of x equals 6x power 2 plus 6x minus 12. This is the first derivative. And the second derivative, f double dash of x equals 12x plus 6. Here is plus. And we know that at the inflection point, so f double dash of x equals 0. Must equal 0. Must be equal 0. So 12x plus 6 equals 0. And from that, we get x equals negative half. Now, we will check the behavior of the function around the x equals negative half by drawing the number line. So, we will draw a number line from negative infinity to infinity, because this is the domain of the function f of x equals 2x power 3. It is polynomial, so its domain equals r. So we write here negative infinity and infinity. Here we have x equals negative half. Substituting x equals 0, it is greater than negative half, where in f double dash, so f double dash of 0 equals positive 6. So here we have positive, and substitute x equals negative 2 less than negative half. You will get here a negative number. So the function is convex here upwards and convex here downwards. So second derivative, f double dash, it changes its sign about or around x equals negative half. Okay, so we can say the curve of the function f, where f of x equals 2x power 3 plus 3x squared minus 12x plus 5, has inflection point at x equals negative half. And we write negative half. Okay, so the solution is D. Next question. Question number 7. If the integral of f of x dx equals 0, it's from negative 2 to 2. Then f of x equals, okay, we have a rule. If the integration equals 0, from negative 2 to 2, from negative a to a, so the function f must be odd. What is the odd function here in this part? Okay, let us check it. Okay, by taking here a, we have f of x equals x squared plus 1, right? So f of negative x equals negative x power 2 plus 1, which equal x squared plus 1. So the function here is even. Okay, here f of x at b equals x. So f of negative x equals negative x. And the negative x equals negative f of x. Here we get f of negative x equals negative f of x, so f of x is odd. Okay, so the solution at letter B. Here, of course, f of negative x equals x squared plus 1, and x squared plus 1 is f of x itself. Okay, so the function is even. Why? Because f of negative x is f of x equals f of x. Here, f of negative x equals negative f of x. So this function is odd. So the solution will be at letter B. If f of x equals sine 2x cosine 2x, then f double dash of pi over 3 equals one of this. So we must simplify the right hand side. Okay, we know that sine 2 theta equals 2 sine theta cosine theta. Okay, and we can say that half sine 2 theta equals sine theta cosine theta. Okay, here we have 2 theta, and in the right hand side we have only theta. Okay, here is double the angle, so we can say half sine 4 theta equals sine 2 theta cosine theta. Okay, this is in general. Okay, back to our function. We have here f of x equals sine 2x cosine 2x. Okay, so applying this rule, we can say that f of x equals half sine 4x, and f dash of x equals 4 multiply half equals 2 cosine 4x again, and the f double dash of x equals 4 multiply 2 equals 8. The derivative of cosine is negative, so we have negative 8 sine 4x. The required here is to find f double dash pi over 3. So f double dash pi over 3 equals negative 8 sine 4 multiply pi over 3. Okay, and you can calculate it using calculator, but don't forget to put first, we make it in this mode, and we change D to BR, shift mode. Okay, the radian at number 4. Okay, and we write negative 8 sine, okay, 4 pi over 3, 4 pi over 3, and close the bracket. The result equals 4 root 3. Okay, and we will choose letter C. Okay, question number 9. here y equals sine x all power tan x. Y equals sine, okay, sine x all power tan x. So dy dx equals, to make the first derivative here, we must take the natural logarithm to both sides. So we will get ln y equals ln sine x power tan x. And we'll use the properties of logarithm. So ln y, before we make any derivative, equals tan x ln sine x. Okay, we take the power here out of the logarithm, natural logarithm. So we have ln x, tan x multiply ln sine x. Okay, now by taking the derivative to both sides, the derivative of ln x is y, 1 over y, dot the derivative of y itself. So we have y dash. Again, the derivative of ln y equals 1 over y dot y dash, the derivative of this function. Because we make a derivative here with respect to x. Here we have two functions, tan x and ln x. So to make the derivative to the right hand side, we make the derivative as first to tan x. The derivative of tan x is sec square x multiply ln sine x. Okay, plus we keep tan x multiply the derivative of ln sine x. So it will be 1 over sine x. Here, multiply the derivative of sine x. What is the derivative of sine x? Is cosine x. Okay, and we simplify this part. Here we have, so y dash equals y multiply sine, sec square x dot ln sine x plus tan x multiply cosine over sine is cotan, and the tan multiply cotan equals 1. And we know that y equals sine x power tan x. So the solution here, it will be in letter A. So our answer here is in letter A. Next question. Question 10. The height of a right circular cone equals its base diameter. So I'll start with drawing the right circular cone. Okay. First we draw this triangle here and remove it here. And we draw its base. Like this. Now, the height of a circular cone equals its base diameter. So the diameter here and its height from here to the base, if the diameter equals 2r. So the height equals the rate of change of its base radius. It means dr dt equals 1 over pi centimeter per second. Okay, then the rate of change of its volume. Now, what is the volume of the right circular cone? The volume equals 1 over 3 multiply area of the base by r square multiply height. The height equals 2r. Okay, 2r, because its height equals the diameter of its base. So v equals 2 over 3 pi r power 3. And here we have the rate of change of its volume. It is required. So the required is to find dv dt, which equal, here the variable here is r, so we have 2 pi r square dot dr dt. But dr dt equals 1 over pi. It is given here. And its base radius equals 5. So by substituting r equals 5, we will get 2 pi times 25, as 5 square equals 25, dot or multiply dr dt equals 1 over pi. Dividing up and down by pi, so we will get 50 centimeter power 3 per second. So the solution will be in letter D. Integration of x square e power x dx equals one of these plus c. Here we have integration by partition. So we have here two functions, x square and e power x. So we write here differentiation, and here is integration. We'll make a differentiation to x square and integration to e power x. The first derivative equals 2x, the second derivative equals x equals 2, the third derivative equals 0. Here we stop and we make integration to e power x. The first time equals e power x. Integration again equals e power x. The integration of e power x is e power x. Okay, and we draw this map here like this, and we complete the integration of x square e power x dx equals, okay, here we start with positive, then negative, then positive. Okay, x square multiply e power x, x square dot e power x minus 2x multiply e power x, again 2x multiply e power x, then plus 2 multiply e power x. So we'll get 2 e power x. Where this result here this result x squared dot ex minus 2x e power x plus 2 e power x in letter B. Question number 12. Here, the opposite figure represents the curve of the function f double dash. Then the curve of the function f has an inflection point at x equals 0, 1, 2, or 3. Okay. We know that at the inflection point, f double dash equals 0. Okay. Here, f double dash of 2 equals 0, right? F double dash of 2 equals 0 because the curve of or the figure which represent f double dash is a straight line here, and it cut x-axis at 2. So at this point, we have 2 and 0. So you can say that f double dash of 2 equals 0. So there is an inflection point when x equals 2. When x equals 2, and the solution will be letter C. Okay? Next question. Question number 13. In the opposite figure, ABCD is a square of side length equals 24 centimeters. AF equals 2AE. AF equals 2AE. So if AF equals 2x, so AE equals x. Because AF equals 2AE, okay, let EA equals x, then the length of AF equals 2x. Okay, then the greatest area of the figure FBCE. FBCE. The required here is to find what? The greatest area. The greatest area of this figure. Okay, this quadrilateral. The area of this figure here equals the area of the square minus the area of these two triangles. Triangle EDC plus the triangle EAF here. So we start from the beginning here. Area of the figure FBCE equals the area of the square, the side length of the square equals 24 centimeters, right? So its area equals 24 multiply 24, as the area of a square equals side by side minus the area of this triangle EAF. Its area equals half multiply base multiply height multiply 2x, okay, plus the area of the other triangle. Here we have DA equals 24, so DE equals 24 minus x, okay, and DC also equals 24. It is the length of the side length of the square, 24 centimeters. So what is the area of this triangle EDC? Equals half multiply its base, which equal 24 minus x multiply its height 24. Okay, so let the area of the required figure is A. So the area equals 24 multiply 24, 24 square, 24 power 2 equals 576. 576 minus, we simplify this part, half multiply x multiply 2x equals x power 2. Okay, plus half multiply 24 equals 12. 12 multiply 24. 12 multiply 24 equals 288. 288. Okay, and the 12 multiply negative x equals negative 12x. Okay, so the area A equals, here we have negative x square plus 12x, as negative multiply negative equals positive 12x, and 576 minus 288 equals 288 plus 288. Here is the area of the figure FBCE, and the required here is to find the greatest area. To find the greatest area, we make the following steps. First, we will find the first derivative, dA dx, the first derivative of the area, dA dx equals negative 2x. The derivative of negative x squared is negative 2x, plus the derivative of 12x is 12. The derivative of 288 equals 0. Now put dA dx equals 0. It means negative 2x plus 12 equals 0, implies x equals 6. Okay, now we check the sign around x equals 6. The sign of what? The sign of dA dx, or we can use second derivative to determine this critical point, if it maximum or minimum. Okay, it's easy here to check it using the second derivative of the area. What is the second derivative? d2a dx square equals negative 2 plus 0. Okay, and d2a dx square when x equals 6 also equals negative 2. It is constant, less than 0. Here we have the second derivative is negative. So there is a maximum value to the area when x equals 6. Again, the second derivative is negative when x equals 6. Okay, there is no x here to make a substitute. But in general, in this problem, in this question, we have the second derivative is negative. So it means the area has a greatest value when x equals 6. And this value, A, equals, here is the required, is to find the greatest area. So the greatest area will be negative 6 power 2. Here we substitute in this part because A equals negative x squared plus 12x plus 288 plus 12 multiply 6 plus 288. And then we go to calculator and we start again. Negative 36 plus 12 multiply 6, it is 72 plus 288 equals 324. So the greatest area equals 324 centimeter power 2, as the unit here is centimeter power 2. And we'll choose letter A. Next question. Question number 14. The area of the region bounded by the curve y equals x power 3. And the straight lines, the two straight lines, x equals -1 and x equals 1 and y equals 0. Okay, equals. First, we'll draw this part, this curve, quickly. To draw the function y equals x power 3, now you can substitute x equals -2. The result will be -8, right? When you substitute equals 1, x equals 1, so y equals 1, substituting x equals 0, and so on. Okay, so the figure will be in this form, like this. It is the third degree function, y equals x power 3. Okay, okay, now here the area bounded by these 3 straight lines. Y equals 0 is x-axis. Here, this is y equals 0. Okay, and x equals -1 with straight line passing through the point -1. Okay, here. Consider this point as -1 and y equals 1. Okay, okay, like this. So the required area is this area here. I'll try something here. And this area. So, but if you calculate the area here, it will be negative because it is under x-axis from x equals -1 to 0 and from 0 to 1. So the area equals absolute of the integration from -1 to 0 x power 3 dx absolute, okay, plus this part of the area will be positive, so no need to write absolute. Okay, so it will be the integration from 0 to 1 x power 3 dx. From symmetric, you can say that the two parts are equal, the two areas are equal. A1 equals A2. So A equals 2 multiply the integration from 0 to 1 x power 3 dx. Now you can calculate it from your calculator to multiply the integration of x power 3 from 0 to 1. Okay, the result will be half, equals half, and the solution will be at letter B. Question number 15. The equation of the curve y equals fx. If y double dash, this is a given, y double dash equals 6x minus 4. And the curve has a local minimum value at 1, and 5. It means, what is the meaning of this statement? That means f dash of 1 equals 0. Okay? And also the curve of this function passing through the point 1 and 5. Okay? The required here is to find f of x. And we got here y double dash. So we will use integration. First, to find y dash. Okay? Y dash equals the integration of 6x minus 4 with respect to x, which equal 3x squared minus 4x plus c. Okay, now we want to calculate the value of c. As I said, f dash of 1 equals 0 because the curve has a local minimum value when x equals 1. It means f dash of 1 equals 0. It's a critical point. Okay, so 0 equals 3 multiply 1 square minus 4 multiply 1 plus c. 0 equals 3 minus 4 plus c. It means c equals 1. So y dash, or you can say f dash of x equals 3x squared minus 4x plus 1. Okay, but the required here is to find f of x. So we'll make integration once more. F of x equals the integration of f dash of x with respect to x. Integration of 3x squared minus 4x plus 1 dx, which equal, by adding 1 to the power here, it will be 3, and we'll divide by it, equals x power 3 minus 4 divided 2 equals 2x squared plus x plus c dash. Okay, it is the second constant in this question. Okay, now we know that there is a local minimum point at the point 1 and 5. So it means the curve passing through the point 1 and 5. When x equals 1, then y equals 5. We will use it to get, so 5 equals 1 plus 1 minus 2 equals 0, c dash. It means f of x equals x power 3, okay, minus 2x squared plus x plus c dash, which equal 5. And this result, x power 3 minus 2x squared plus x plus 5 at letter A. Question number 16. Here, the curve of the function f of x equals x minus 2 multiply e power x is convex downwards in the interval. So to find it, we must find the second derivative of f of x. So we have, first we can simplify f of x. So f of x equals x dot e power x minus 2 dot e power x. So f double dash f dash of x equals f dash of x equals the derivative of the first is 1 dot e power x plus the first dot derivative of the second e power x minus the derivative of 2e power x is 2e power x itself. So f dash of x equals e power x minus 2e power x plus x dot e power x, which equal x dot e power x minus e power x. Okay, this is f dash of x. Now f double dash of x equals the derivative of the first is 1 dot e power x plus the first derivative the second minus e power x itself. E power x minus e power x equals 0. So f double dash of x equals x dot e power x. Now put f double dash of x equals 0. It means x e power x equals 0. And this happens only when x equals 0. And we check the sign around x equals 0. Sign of what? Sign of f double dash. Okay. Here we have x f double dash. Here we have 0 and 0. You can check some numbers for x less than 0 and greater than 0. Less than 0, e power x always positive. So the sign of x dot e power x depends on x. When x is negative, the whole term will be negative, like this. And when x is positive, greater than 0, so f double dash will be positive. So in this part, the function convex downwards, and in this part, convex upwards. Back to the question again. The function is convex downwards in the interval from 0 here to infinity. From 0 to infinity here at letter D. From 0 to infinity. Next question number 17.